Hello friends, welcome to my channel. Today I will be discussing about the drug molecule Tepotinib, which is an approved drug for the treatment of non-small cell lung cancer. Here is the chemical structure for the molecule. This drug was developed by Merck KGaA company from Germany. The molecule was first time synthesized in the year of 2009 through 11 steps. Later, they have modified the reaction route, which contains 8 steps. So first I will discuss that route. So the first step of the reaction sequence is the palladium catalyzed Suzuki-Maillard coupling reaction in between this aryl boronic acid and this bromo and iodo substituted heterocyclic ring to form this carbon-carbon bond. So here they have used palladium chloride, bis triphenyl phosphine as the catalyst 1 mole percent and toluene as the solvent in presence of sodium carbonate base. And second step is the thionyl chloride mediated conversion of this primary alcohol into the primary halide. And then they have used another heterocyclic ring which they have synthesized from 3 acetyl benzonitrile, and in alkylation of this heterocyclic ring they have done by doing reaction with this primary halide in presence of potassium carbonate in NMP solvent under heating condition to get this intermediate. And here they have performed another palladium catalyzed Suzuki coupling reaction to install boronate group by replacing this bromide. So B2P2 they have used as the boronating reagent in presence of potassium acetate, and solvent they have used DMF to get this aryl boronate intermediate. And here sodium perborate mediated hydrolysis of this boronate ester was performed to convert it into the alcohol. And next they have performed one Mitsunobu reaction with this primary alcohol which is attached with one Bock protected piperidine ring. And for this Mitsunobu reaction they have used this diode reagent which is diisopropyl azo dicarboxylate in presence of triphenyl phosphine. They got this intermediate, and in the final step it was N-methylation using formic acid in presence of formaldehyde to get the final compound tepotinib. So this is overall 8-step process, and overall yield of the final product was 27%. And there are few drawbacks in this process, like they have used toluene solvent in this palladium catalyzed reaction, and here you can see NMP and DMF. So these solvents are actually not user friendly solvent, like NMP, DMF, these are toxic solvents. And also you can see palladium catalyst they have used quite higher mole percent, like 1 mole percent, 3 mole percent. That is also not a very desired condition for large scale synthesis of the molecule. So now I will be discussing another modified route which was developed by Professor Lipsuz from University of California, Santa Barbara. So instead of following any linear synthetic route, they have opted one convergent synthetic route. They established total 5-step process. So they have synthesized 2 different fragments separately and they coupled those two fragments. I'll discuss here in details. Like first step is like Suzuki-Miura coupling reaction between this bromo heterocycle 2 and this metacyano phenyl boronic acid. And for this coupling reaction, they have used palladium Pepsi complex as the palladium catalyst. So you can see here they have used 400 ppm of the palladium as catalyst. So it's much lower concentration. And triethylamine has been used as the base, and they have used ethanol water mixture as the solvent. And TPGS 750M they have used as the surfactant. So these surfactants are usually used for palladium catalyzed coupling reaction which are performed in water. They have got excellent yield of this coupling product, 99%. And next step was the N-alkylation using this boron substituted benzyl bromide and in presence of K3PO4 as the base to get the intermediate 5. And other way, they coupled between this heterocyclic compound with this alkyl bromide in presence of base, substitution reaction product, intermediate 8 was obtained, and next step was N-methylation using formaldehyde in presence of formic acid to get the intermediate 9. Now they coupled intermediate 5 and intermediate 9. This is an palladium catalyzed Suzuki-Miura coupling reaction. You can see it's bisphenol bisphenol ester and this aryl halide coupling. And here they have used this palladium chloride amphos as the catalyst. Here is the structure for the catalyst. They have used only 700 ppm of the catalyst in presence of K3PO4 as the base. And here also you can see solvent was used with the mixture of ethanol and water in presence of surfactant. Here also they have used the same surfactant. You can see TPGS 750M, and a reaction was performed at 60-degree temperature to get the final product tepotinib. So this is a convergent 5-step synthetic process, and here they got overall 75% yield. So the key advantage of this new modified process is this route is more sustainable, where they could avoid some toxic solvents like NMP, DMF. You can see most of the reactions were performed in ethanol water. Yeah, that's all. Thanks.